Example 2U. Auscom's rates for local calls from private telephones consists of a quarterly rental fee of $40 plus 25 cents for every call. Construct a cost function that describes the quarterly telephone bill. Your first step in any worded situation is to use a highlighter or a pen to identify the important pieces of information. So the important pieces here is $40 for the rental fee, 25 cents for every call, and that what we're actually asked to find is the cost function. And it's the cost function that describes a quarterly telephone bill. If this wasn't a quarterly telephone bill, then this quarterly rental fee would have to be adjusted. So for instance, if this was a yearly telephone bill, you would have to take your quarterly rental fee and times it by 4. So this is a very important piece of information. Okay, we're up to constructing our function. Because we're given information that C equals the cost of the telephone and that N is the number of calls, you must use C and N. So in this particular case, I'm going to have the cost is equal to. Now I need to use the information that I'm given up here. Now I have $40 and I've got 25 cents. So I have to have these in the same units. So I'm going to convert this 25 cents into dollars, which is 0.25. And we know that we've got 0.25 for every call, and the number of calls is equal to N. So if we multiply both of those, we'll get the amount of money it costs in total based on the number of calls. In addition to that, we've also got the fixed cost of $40. So for every quarter, it's going to cost $40. So if we add the $40 to our function and we put a red box around it as that's our end answer. So the cost function is equal to 0.25 lots of N, where N is the number of calls, plus $40, which is the fixed quarterly rental fee. Now the question doesn't ask us to graph this. However, we will do that as an addition to this as well. So in order to graph this, the very first step, or the easiest step we can do, is to recognize that we have a y-intercept of 40, so we can actually put in a y-intercept of 40 on our graph. That's the easy part. We need a second point. To be able to graph it linearly, we need a second point. You have more than one option. You could use your gradient, 0.25. However, as it's such a minute change over such a large n value, that would be a very difficult graph to plot. Instead, I'm going to choose to substitute in n equals 200 into my equation, and then if I just solve for the cost, I end up with a value of 90. So the cost is $90 after 200 phone calls. So I've put in my second point, draw a straight line between the 2 points. It doesn't end here, it does continue, so I put in an arrow at the end and that's now plotted. So if I was after the cost of, let's say, 150 phone calls, I could approximately read that off the graph as being about $75. Now that's an approximate, it's not exact.